Yo, what's good? Welcome back, math fam, to How to Algebra. Today, we're unlocking the power of determinants. First, for a 2x2 matrix, it's simple. Multiply the diagonals and subtract, and boom, you've got the determinant. Now, for a 3x3 matrix, we've got two solid methods. First up is expansion by minors, or the cover-up method, as I like to call it. Break down the matrix into 2x2 pieces and solve for the determinant, which I'll show you here in a minute. The second method is the diagonal method, one of my least favorite, but it's still effective, where we extend the matrix, multiply the diagonals, and subtract. Both methods lead to the same result, and I'll show you exactly how. Ready to dominate the determinants? Let's get it. All right, so we're looking at finding the determinant. The process is fairly easy to pick up, particularly in a 2x2 matrix, right? 2 rows, 2 columns. In a 3x3, it does get a little bit more involved. So let's see. All right, so the process goes like this. You start in the top left and you multiply to the bottom right. That's step one. So A times D. And you always subtract. Right? It's always minus. It's always minus. And then it's the other diagonal. So C times bottom left times upper right. So if you kind of burn this into your mind, I guess, AD minus CB. It's the top left times the bottom right minus, always minus, bottom left times top right. So it makes like an X, right? It kind of makes like an X. All right, so this is how you find the determinant of a 2x2 matrix. Like I told you, it was simply put, like it's fairly simple. So the answer, right, this will be a number. This is going to come out to be some sort of figure. Just know that we can do some interesting things with this number later on in the future. Right now, it's can we get to the determinant, right? Like I just need you to be able to find this number, be able to do this process. Because once you're able to do this process, then we can apply this idea to finding the determinant of a 3x3, or using Cramer's rule, which again, we'll get into in a minute, but it relies on knowing this process, right? So there's finding the determinant, and then there's a rule that we use to apply the determinant to find the solutions to a matrix, right? X, Y, and Z, or whatever the variables may be. So let's see an example. All right, I want to find the determinant of this matrix, right? So we have 3, 5, 2, 6. Again, you multiply the diagonals. So 3 times 6 minus, right? Always minus. And then bottom left times top right. 2 times 5. We do this calculation. We see 3 times 6 is 18. Minus 2 times 5, which is 10. And we get 8. All right, I mean, it's very straightforward, right? There's no hidden tricks at the moment. It's very straightforward. See another example. And I think this should solidify this idea. So to find the determinant, we take the diagonal, top left times bottom right. So -2 times 8, always minus, right? It's always minus. Bottom left times top right. So 5 times 7. We get -2 times 8, which is -16, minus 5 times 7, which is 35. So here's where you got to be careful, right? That if you're going to make a mistake, it's going to be with the negatives that are scattered everywhere, and you're going to be minusing a lot of negatives, right? Like it's just in your future, right? So -16 minus 35, the answer is going to be negative for sure. And this number is just going to get larger. This is going to be 51. So -51. All right, so that's the determinant of a 2x2. So now let's do a 3x3. All right, so to start with finding the determinant of a 3x3, the process is a little involved, right? As a matter of fact, there's two techniques. I'm going to show you both. Typically, you'll gravitate towards one of them. They're both pretty much the same as far as the result, right? No matter which one you do, you're going to get the same determinant. It's all preference. I'm going to start with my personal favorite. Okay, so this is called the cover-up method. It's probably called something else, but this is how I was taught. So what you're going to do, either with your pencil, your finger, your mind, you're going to cover up the first column and the top row. Now, when you do this, it leaves behind a 2x2 matrix. So the way it works is that whatever value is at that intersection, right, of the row and the column is going to be multiplied by the determinant of this resulting 2x2. So it's A times the calculation that we did for a 2x2, right? The finding the determinant of a 2x2. So this would be top left times bottom right. So E times I minus, right? Always minus the bottom left times the top right. Now I get it. This is very abstract right now because there's letters, but you just need to realize the process first. And then once you get the process down, the numbers will be a lot easier in my opinion. Okay, so that's step one. We're going to do this 3 times, a total of 3 times. So this was step 1. So this is how you find the first part. Okay. Then, part of the process, it's always minus. The second part is always minus. That's just the way it is. There's reasons behind it, but it's beyond the scope of what we're doing here, right? This is just showing you this process. Basic entry-level stuff. Okay, so minus, right? Now we have the second part. Again, in your mind, I want you to block out now the middle column and still top row. Now notice that intersection, that's what we're going to multiply this next piece by. Kind of like the first. Okay, there is a 2x2 matrix that is formed. DF, G, and I. Right, these 4 remaining, after you block out the column and row, there is 4 values that make a 2x2 matrix. All right, and we do, again, top left times bottom right. So D times I. Again, always minus. Bottom left times top right. G times F. And that's that calculation. All right. For the third part, so that was number 2. So for the third part, we add. Right, we add. We only subtract the second part, the second term, like the second part of the process, rather. Okay. Hopefully you can see where this is going. In your mind, we block out the last column and still the top row. Now, the letter at that intersection gets multiplied by the determinant of the resulting 2x2. So this is going to be D times H minus, right? Always minus G times E. Bottom left times top right. That's an E. And there you have it. That's the determinant of a 3x3. Now, you're not going to leave it like this, obviously. In a moment, there's going to have values. and you're gonna have to calculate these values, either by hand or with the calculator. Just keep track of the negatives and make sure that the negatives are where they need to be. So let's see an example, and then I'll work that same example using another method. All right, for this example, we have a 3 by 3. We want to find the determinant of this 3 by 3. So I'm gonna do the cover up method. Now, I'm highlighting and erasing just because I have technology, right? But normally, you wouldn't color in and then erase. Like, it just takes too much. So you can either use typically like your finger, or just do it in your mind, right? Just do it in your mind. But what I want you to do is block out these 2 rows. We've identified the value that's going to get multiplied, right? So 1, that's actually nice, times the resulting 3 by 3, or correction, the resulting 2 by 2. So -5 times 1, 4 times -1, right? Minus, always minus 4 times -1. All right, that's the first part. Minus, again, that second part of the process is always minus. Now we cover up top row and the middle row. Again, the value 2, that's what's going to get multiplied, times, all right, the resulting 2 by 2, which is kind of, it's not too difficult to see, but 3 times -1 minus 4 times -1, or 3 times 1 minus 4 times -1, plus, all right, in your mind, block out the top and the last column. So the last number, -3. So -3. That's going to get multiplied by the determinant of this resulting 2 by 2. So we have 3 times 4 minus 4 times -5. Okay, there it is. So we can start our calculations, right? It's just keeping track of the negatives. Notice there's negatives all throughout this thing. All right, starting with the first piece, we have -5 times 1. So -5. And then negative is a positive, so +4. And this is going to be -5 plus 4, -1. And then obviously times 1, but I don't worry about that. All right, second piece. We have 3. This is going to be negative times the negative is a positive, 4. So this is going to be 7, right? Times 2, -2. So -14. And then for the third piece, 3 times 4 is 12. Negative and a negative is a positive. 4 times 5 is 20. This is 32. Times -3. 2, 4, 6. 96. -96. All right. And now we just combine all these numbers, right? -1 minus 14 minus 96. We get, handy dandy calculator tells us, -111. Not bad. The determinant is -111. Okay, that's the first method. All right, going back to our instructor matrix. So if I want to find the determinant of a 3 by 3, and I don't want to use the cover up method, say you don't like that method, well then another option would be the one I'm about to show you. So here you have a 3 by 3. Well, the first step is to take the first 2 columns and rewrite them after the matrix. So what I'm saying is A, D, and G. Right? I'm just rewriting it. Then B, E, H. Okay. Step 1 is going to be multiply the diagonal. So it's going to be A times E times I plus the next diagonal, product of the next diagonal, B, F, G, plus the product of the next diagonal. Now notice, right now it's just letters, so this is like fairly easy to comprehend. However, these numbers could get quite large very quickly. So notice all this multiplying is one of the reasons why I shy away from this particular process. In the other process, or in the other method, there's not as much multiplying. Okay, so now this is where technique comes in. So you add the products on the main diagonals going down. All right, me personally, I subtract the products going up. So minus G times E times C minus the product of the next diagonal going up. H times F times A minus the last diagonal. I times D times B. Now, some other people might suggest another way of grouping the negative numbers together. Me personally, I just like to subtract it as I go. Now, one way you might see it is they do the minus for sure. However, they put parentheses, and in the parentheses, they do the same diagonals, except they add them. This is another way. So if you add up the diagonals and then at the end distribute the negative to just one number, I guess, is a way. I just subtract. So that's solely up to you. It's technique. Like there's no one way like, oh, you got to do it this way. Like no, it doesn't. You do it the way that feels most comfortable to you. All right, so let's see an example using this method. I'm going to rewrite the first two columns, 1, 3, 4, 2, -5, 4. So we just rewrite the first two columns. I'm going to multiply the first diagonal. So 1 times 1 times -5, -5. Second column, 2 times 4 is 8 times -1 is, so plus -8. I could have wrote I could have wrote just -8, but I want you to see that you're adding the numbers together. I don't want you to think that I'm subtracting the numbers. But you could most definitely write -5 -8 or -5 -8. Again, plus the next diagonal. -3 times 3 is -9. -9 times 4, -36. Again, it's minus, right? That's part of the process that I teach. So this next diagonal, -5 times -3 is +15. 15 times 4, 60. Minus the next diagonal, 1 times -1 times 4, -4. And then lastly, the last diagonal, 1 times 3 times 2, -6. Okay, so let's start combining like terms. So on the left in red, we're adding all these negative numbers together. So this is going to be 8 and 5 is 13. 13 and 36 minus 49. On the right, we have, so a couple adjustments here. This is going to be plus. So negative 66, right? Negative 60 minus 6 is negative 66. Plus 4 is negative 62, which comes out to negative 111. Again, that's what we expected, right? Because we had already done this problem. But these are the two methods. So hopefully you gravitate towards one or pick up both. Like, I'm comfortable with both. I just have the one that I like. All right, Cramer's rule to solve a system of equations. So the idea is I want to have a system, right? Two variables, two rows, two variables system. And I want to solve for x and y, the variables. Now, we can use Cramer's rule. Well, technically, we could use anything, right? We could use substitution method, right? Things that we know. We could elimination method. We could solve for y, graph, and see where the lines intersect if they even do. But we do have this nice process. It's not nice. Really, you wouldn't go for this process just out the blue. You really have to be asked to do this because there's so many more efficient ways, I think. But this is a good process to know, right? It's Cramer's rule. So the way it works is that you first create the matrix of the coefficients: 2, -1, -3, and 4. Now, for this to work, the x's have to be lined up, and then the y's have to be lined up. Okay, then we have a second matrix of just the answers, or a 2x1 for just the answers. So what's going to happen is we're going to use the rule that we learned about determinants, like solving a determinant of a 2x2. We're going to do that. Then we're going to swap out the x columns for the answers and then solve for the determinant again. Then we're going to do the second thing. We're going to put the original x's back, then swap out the y's, and then solve for the determinant again. And then we'll take a ratio of the answers. So you'll see what I'm talking about here momentarily. Okay, so first off, so they've already done it, right? They've already done it. So we're going to first just figure out what the determinant is of the coefficients. So we're going to multiply and subtract the diagonals. So 8 minus -3 times -1 is +3. So -3, which is 5. Okay, now we're swapping out the x column. We're taking out 2 -3 and we're replacing it with 6 3. That's exactly what they did here. And then we solve for the determinant again. So this diagonal, 6 times 4 is 24, minus 3 times -1. 3 times -1 is -3. Therefore, +3, which is 27. Hopefully you can follow that. Okay, we're putting back in the original. And now we're swapping out the answers for the y's. And that's exactly what they did here. So we're removing -1 4 and we're replacing it with 6 3. So we have this diagonal, 6 minus the other diagonal, -18. So +18. And that's going to be 24. Okay. So now that we have our determinant, we have our big X and big Y, we're going to take a ratio of these. The ratio is going to look as follows. So we have, put everything in the screen so we can see it. So little x is equal to big X over D. So this is going to be 27 over 5. That doesn't reduce anymore. Then we have big Y over D, which is 24 over 5. Again, that doesn't reduce anymore. So the x and y solutions to this particular system is 27 over 5, comma 24 over 5. It's kind of interesting. Is it efficient, right? Is it faster than doing substitution or elimination? I don't know. Depends on you, I guess. But this is the process. So let's see it again in action. Okay. Here's the one example. Use Cramer's rule to solve. I bet. Notice x and y are not on the same side of the equation. So I need to subtract 3y minus 3y. So I'm going to get 2x minus 3y is equal to 9. On the bottom, x plus 5y equals negative 2. No change, right? So my matrix is going to look like this. It's going to look like 2, 1, negative 3, 5. The answers, they're in their own matrix that we're going to use later. All right, finding capital D first. We're going to do the diagonals. So 2 times 5 is 10, minus 1 times negative 3, negative 3. So plus 3, right? Minus a negative is plus. This is 13. All right, that's my D. Then capital X, we're going to replace the X column with the answers. So 9 minus 2, negative 3, 5, right? That's going to be, the diagonals are going to be 45 minus positive 6, right? Negative, negative is a positive, so positive 6. That's going to be 39. All right, capital Y. This is going to be the original X, right? X has to go back, so 2, 1, and just Y gets replaced. 9, negative 2. So these diagonals are going to be negative 4 minus 9, negative 13. Okay, now we take the ratio, right? So little x is going to be big X over D, which is 39 over 13, which is 3. Little y is going to be big Y over D, which is negative 13 over 13, which is negative 1. Okay, so the solution to this particular system using Cramer's rule is 3, negative 1. It's a process. I know that I went fast in the calculations, but it's really just multiplying and subtracting. All right. Hopefully this helps someone. Catch you guys in the next video.